Hello children, again I am here your chemistry teacher Hema Marwah to present part 2 of chapter 1 Matter and its composition for the class 7. Hope you all are fine and safe at your home with your parents and started working on your assignments. Our assignments must be keeping you busy to upgrade your knowledge in the lockdown period. Students, for your recall, I would like to focus on the topics which we have already taken in the part 1 of lesson Matter and its composition. Subtopics which we have already discussed in detail were definition of matter, volume and mass, properties of matter, three states of matter, that is solid, liquid and gas. And then finally we discussed about the properties of matter, that is intermolecular space, shape and volume, compressibility, fluidity. I hope all of you must have learned the definition of these properties and definitions which we have covered in the subtopic. Now for your recollection, I have again drawn a diagram of solid, liquid and gas in which arrangement of molecules is very clear. As you see in the first diagram of solid state of matter, you will find molecules are tightly held together. There is no space in between the molecules in case of solid. Therefore, it will result into highest intermolecular force of attraction in case of solid state of matter, and there will be negligible intermolecular space between molecules in the solid state of matter. Coming on the second figure or the diagram, you will find molecules are a little bit farther from each other. In other words, you can say molecules have developed a little more intermolecular space in between them. Hence, liquids have less intermolecular force of attraction as compared to solid molecules. Coming on the third diagram of gaseous state of matter, you will see molecules are quite apart. In other words, they can move randomly. Why it happens? For your recollection, again I am telling, because intermolecular force of attraction between molecules is negligible in gaseous state of matter. Children, now next property which we will discuss is thermal expansion. When you will listen this word, first question will click in your mind is, what is thermal expansion? In simple words, I would like to explain it for you. Thermal means heat and expansion means increase in size, shape, area or volume. Therefore, thermal expansion is the expansion on being heated. The thermal expansion of a solid is very small. That of a liquid is larger and that of a gas is largest. Why it happens? Because on being heated, the molecules absorb energy. So as they absorb energy, they move farther apart. The smaller the intermolecular force, the farther the molecules will move, and the larger is the expansion. Hence, you will find thermal expansion of solid is less due to strong intermolecular force of attraction between molecules. Thermal expansion of liquid is more as compared to solid, and thermal expansion of gas is maximum because intermolecular force of attraction is negligible in gaseous molecules. Children, this is the diagrammatic representation of thermal expansion. This diagram is showing that when you will heat a substance, expansion will take place. You can see how the liquid expands on being heated. In this slide, children, I have taken one example from your daily life. You must have enjoyed Kisan fruit jam in your childhood and have experienced that sometimes it is hard to press it open. Then you must have observed that your mother must be taking it under tap with lukewarm water to open it. So same thing I have shown in this picture slide to make a clear picture of thermal expansion. When a jam bottle cover doesn't open, it is immersed in hot water, and then what will happen? It will expand. It expands due to heat and opens up easily. So this is a very good and best example from your daily life to understand the thermal expansion. Children, now we will discuss the principle of thermal expansion. When a substance is heated, its molecules absorb energy and move away from each other. I repeat, when a substance is heated, its molecules absorb energy and move away from each other. If intermolecular force is high, and where you will see the highest degree of intermolecular force, you will find it in solid state of matter. The particles do not move much. Therefore, expansion is less. Therefore, thermal expansion is less. If intermolecular force is less, as you notice in the liquid and the gaseous state of matter, the particles move apart more. Therefore, expansion is more. This principle I have tried to show you through a diagram also. At the right side, you can see the diagram of thermometer bulb. In the thermometer bulb, as you know, mercury is filled. Mercury is a type of liquid which is metallic liquid, you can say. As soon as heat is provided, the molecules of mercury will try to be apart from each other due to less intermolecular force of attraction and more intermolecular space. So this diagram clearly shows that as soon as you will provide heat to the liquid state of matter, there is thermal expansion. Now the next topic we will take is change in states of matter. Children, you see, like water, other substances also change their states on being heated or cooled to the right degree. So when a substance or matter is heated or cooled to a right degree, it changes its state. This change in state is called interconversion of state. This change in state is called interconversion of state. Interconversion can be between solid and liquid. That means solid can be converted into liquid state of matter, and liquid state of matter again can be reconverted into solid state of matter. Then we can convert liquid state of matter into gaseous state of matter. Again we can convert gaseous state of matter into liquid state of matter. And one more interconversion which we are covering in the book is solid to gaseous state of matter. Now we are going to discuss first category of interconversion, that is solid liquid interconversion. On being heated to a particular temperature, a solid changes to the corresponding liquid. This is called melting of solid. So what happens in a solid? The molecules vibrate about their mean position. On being heated, they receive energy from outside and vibrate with greater energy than before. And slowly what happens? They receive so much energy that they can overcome the strong cohesion of the solid. And as a result, the molecules become labile and solid melts down. Hence, the temperature at which a solid melts is known as melting point. Now let us discuss in brief what is melting and melting point. When a solid is heated at a particular temperature, it changes to liquid. It is known as melting. And melting point, temperature at which it melts, is known as melting point. I have given certain examples for you. For example, melting point of ice is 0 degrees Celsius, carbon 3550 degrees Celsius, aluminium has a melting point of 660 degrees Celsius, and iron is having the melting point of 1535 degrees Celsius. Children, now I want to give a clear picture of solid liquid and liquid solid interconversion through a diagram. This diagram, which you are able to get on the slide, depicts that on providing heat to an ice cube, it changes into water. Same water converts back into ice cube on cooling. Children, now we will discuss what is freezing and freezing point. At a specific temperature, liquid changes to solid. This phenomenon is called freezing. This phenomenon is called freezing. Freezing occurs when liquid is cooled. Freezing occurs when liquid is cooled. During freezing, molecules lose energy and hence they come closer to each other. Cohesion increases and liquid solidifies. The specific temperature at which freezing happens is called freezing point. Now we will discuss the important points of solid liquid and liquid solid interconversion. Freezing point of a liquid is equal to the melting point of corresponding solid. Say for example, freezing point of water is 0 degrees Celsius and melting point of ice cubes is also 0 degree Celsius. A substance will be in the solid state when temperature is less than melting point, and a substance will be in the liquid state when temperature is more than melting point. For example, carbon, aluminium, iron, gold, etc. are solids at room temperature, hence their melting point is more than room temperature. You cannot melt these metals at your room temperature. Water, acetone, etc. are liquid at room temperature, hence their melting point are less than room temperature. Now children, we will take the second form of interconversion, that is liquid to gas interconversion and gas to liquid interconversion. Before taking these two questions, what is boiling and boiling point, I would like to give an easy explanation regarding liquid gas interconversion. Children, when a liquid is heated to a particular temperature, it forms bubbles throughout its bulk. Sometimes you see your mother also, she used to keep a pan on the burner which is full of water, and you can easily recognize the water vapors. So this phenomenon is called boiling, and the corresponding temperature at which boiling takes place is called boiling point. At its boiling point, a liquid gets converted fast into gaseous state. That is why you can see all the bubbles rising from the pan. On being heated, molecules will move little bit farther from each other. The intermolecular force will become too weak to hold them together, and hence liquid state of matter will change into gaseous state of matter. So I have summarized these points into the easy definition for you. The above phenomenon in which the liquid on heating at a specific temperature forms bubbles is called boiling, and the respective temperature at which this conversion takes place is called boiling point. Some boiling points are given in this slide. They are: water has the boiling point of 100 degrees Celsius, glycerin has boiling point of 290 degrees Celsius. Now we will discuss what is liquefaction and what is sublimation. Liquefaction is the change of gaseous state to liquid state. I repeat, it is a change of gaseous state to liquid state. It is also named as condensation. For example, when water vapors are subjected to cooling below the boiling point, they become liquid. At low temperature, gaseous molecules come closer and intermolecular force of attraction increases, and hence gas become a liquid. Now, second question which I am going to discuss in this slide is, what is sublimation? It is seen in some such solids which directly change into vapors without melting. They are called sublime solids. So sublimation is the change of a substance directly from solid to gas state without passing through the liquid state. Camphor balls directly convert a sublime to gaseous state. Now I would like to give you a diagrammatic representation of thermal expansion of matter. Children, you see a diagram on your PPT. This diagram shows that when a solid state of matter is provided heat, it will melt and change into liquid. Liquid, further on boiling at a specific temperature, will change into gas. Gas molecules on condensation, that is on cooling, will convert back into liquid, which further on freezing will convert back into solid. But some solids directly change into gas without undergoing into liquid state. This process is called sublimation. Now I am wrapping up my presentation with few questions which you have to pen down in your assignment copies. First question, what is thermal expansion? What is freezing and freezing point? What is boiling and boiling point? What is liquefaction? What is sublimation? Give a diagrammatic representation of thermal expansion of matter. Thank you.